Okay, so we are looking at dma060, and we're looking at both sections 5 and 6, and both of these sections are on multiplying polynomials. Um, so when we multiply polynomials, you may have, let's say, 2x squared times 3x plus 5. So with the most simplistic of multiplying polynomials, you are using the distributive property and you're going to distribute. So here I'm going to have 6x, and remember the properties of exponents. That's going to be 2 plus 1, so that's going to be 6x cubed. Then 2 times 5 is a positive 10, and I still have the x squared. So you'll be able to use the distributive property when you are multiplying polynomials. So you may ask yourself, what do I do if I have multiple values that I'm having to multiply? So let's say we have x squared plus 5x minus 2. We're going to have 3 terms times 3 terms. So if you have 3 terms by 3 terms, this is one possible way. I personally prefer the distributing method, but I'm going to show you 2 ways to do it. So I'm going to show you what's called the box method if you choose to use this. With the box method, I have 1, 2, 3 terms times 1, 2, 3 terms. So I'll draw myself a box where I have a 3 by 3, 3 by 3. So this one here, I'm going to put on the side x squared, 5x, and negative 2. And then on the top, I'm going to put my 3x squared, my negative 2x, and my 9. What you do with the box method is you are going to multiply the 2 that form the box. So here, this would give me 3x to the 4th. For this box, negative 2x times x squared is negative 2x to the 3rd. 9 times x squared is 9x squared. These two combined give me 15x cubed. These two give me negative 10x to the 2nd. These two give me 45x. These two give me negative 6x squared. Negative and negative gives me a positive 4x. Negative 2 times 9 is negative 18. When you're using the box method, I then, at this point, what I'm going to do is I'm going to combine like terms. Now this one, and I always want to do descending order. So 3x to the 4th is going to be first. My next one is going to be x cubed. I have 2 of these with x cubed. So 15 minus 2 gives me a positive 13x cubed. For my x squareds, I have negative 10 plus 9. That leaves me with negative 1x squared. Oh, whoa, I have 3 of them. Hang on, I'm about to miss one. Y'all have to catch me on that. There we go. All right, let's try that again. We have negative, let me get rid of this here too. We have negative 6 minus 10, which is negative 16. And then negative 16 plus 9 gives me a negative 7x squared. And then these two, 45 and 4, added together give me a plus 49x. And then the minus 18 is all by itself. So what I've done is I have combined my like terms throughout the diagonals here of the box method. And then I make sure everything is in descending order. So that's an alternative that you can use. I'm going to still show you how I do this just in case you might still want to see how to go about doing it with the distributive method. So with the distributive method, if I had, let's say, 2a plus 5, and I was going to multiply that by a squared minus 3a plus 2. what I would do is take my 2a and I would write it times a squared minus 3a plus 2. And then I would take my positive 5 and distribute it with the a squared minus 3a plus 2. So once we have it written out in this form, we then would distribute here. So we are going to distribute, and after we distribute, then we will combine our like terms. So here, to begin with, I'm going to have 2a cubed minus 6a squared plus 4a. Distributing here, I get a positive 5a squared, a minus 15a, and a plus 10. Then I want to combine any like terms. Now the a cubed, there's only in the 2a cubed, there are no more, so I'm going to put descending order. I have a negative 6a squared and a positive 5. That's going to give me a negative 1a squared. The 1 is optional. I have a 4 minus 15 is a negative 11a. And then last, I have the plus 10. That's all by itself. The other method that we talked about was foiling, using the FOIL method. The FOIL method reference to multiplying the first in the parentheses. The outside represents multiplying the outer of the parentheses. The inside are the innermost of the parentheses. And last will be the last terms of the parentheses. So let me just kind of give you a visual for these. So in other words, first, put E there. So for the first, that means in each parenthesis, you're multiplying the first value in each parenthesis. When I say outside, that means you're doing the first in the first parenthesis, the last in the last parenthesis, because that is the outside. The innermost is the second one and the first one and the first one and the second, the two in the middle. And then the last would be the last of each parenthesis. And then after you FOIL, you then combine your like terms. So let me give you an example of how we can use the FOIL method. Okay, let's say we have 2x plus 5 times 3x plus 1. So my first is 2x times 3x. That's going to give me 6x squared. And I'll change colors with each of these so you can see it. Then when I do my outside, that's the outermost. So 2x times 1 is going to give me a plus 2x. When I multiply the inside, that's the inner 2. So for the inside, I have 5 times 3 is a positive 15x. And then when I do last, that's the last of each parenthesis. 5 times 1 is 5. At this point, as I said, the next thing is to combine like terms. So it starts with 6x squared. The 2 in the middle get combined. That's going to give me a plus 17x. And then last, I have just the 5. That's all alone. So that's how we go about doing the FOIL method, which is a review of what we had done the other day. Now, in section 6, we talk about special products. In section 6, I'm going to show you the formulas that you can memorize if you like, but you may also still FOIL. If you have a plus b and it's squared, your answer is going to be the a's squared plus 2 times a times b plus your b squared. If you have a minus b, the same values squared, you're going to have a squared minus 2 times a times b plus b squared. So let's say, for example, we have 3x plus 7 squared. This is my a, this is my b. So for this, a squared, that means we would have 3x squared plus 2 times 3x, actually 3x times 7, and then at the end we would have the 7 would be squared. So 3 squared is 9, x squared is x squared. 7 times 3 is 21, 21 times 2 is 42, and we have an x, so that's a plus 42x. 7 squared is 49. So you can use this formula if it's addition. The only difference is it's a minus if it was a subtraction here. You may solve it in this form, or you may also solve it by foiling. What you can do is take 3x plus 7 and again write it twice because that's what squared means, is twice. And then when you FOIL, your first 3x times 3x, that's your 9x squared. Your outside is the 3 times the 7, so that's plus 21x. The inside is here, that's another 21x. And our last is 7 times 7, and that's a positive 49. The 2 in the middle we combine, so we still get 9x squared. 21 and 21 is 42x, the 49. So when you are working in the next section and you're looking at special products, to me, you can use these formulas and multiply it using the shortcut, or you can simply take the problem that you have and FOIL it. So let's say we have 5x plus 9y squared. So if I'm going to use the FOIL method, I'm going to do 5x plus 9y, and I'm going to write it 2 times because it's twice. I'm going to multiply my first. 5 times 5 gives me 25, and then I have x squared. My outside is 5x times 9y. 5 times 9 is 45. I have 1x and 1y. My inside are these two here. That's another plus 45, x and y. My last, 9 times 9 is 81. Y times y is y squared. All we now do is combine our 2 in the middle. So we have 25x squared. 45 and 45 gives me 90xy. And then last I have 81y squared. The very last item that I have here for us to look at is the sum and difference of two terms. The sum and difference of two terms. So what I have here is if I have an x plus 5 times an x minus 5, I have x squared minus 5x plus 5x minus 25. If you notice, these two terms in the middle cancel out, and we have x squared minus 25. The two in the middle cancel. So the way to write this that they show us in their shortcut form is if you have an a plus b and an a minus b, what you have is your a squared minus your b squared. So if I give you another one, let's say I have x plus 7 and an x minus 7. If I want to use this formula, that means what I have is x squared minus 7 squared. So that would be x squared minus 49. And you may use it either way. You may FOIL and combine like terms, or you can memorize. And this formula here, you'll get to the point that you'll just start to recognize that and be able to do those. But that's all that we have. As for the special products, are the two formulas for the sum and difference of squares and the formulas that we had here if you were squaring where they're both either addition or both subtraction. That's it.